In the next exam question, we have a ball with a mass of 0.5 kilogram, which is projected vertically downwards towards the ground from a height of a building of 1.5 meter at a velocity of 2 meters per second. The position time graph for the motion of the ball is shown below. In this position time graph, we can see that the ball is thrown initially from a height of 1.8 meters above the ground, and it is thrown with an initial velocity of 2 meters per second downwards. For this problem, we will take downwards to be negative, therefore this initial velocity should be negative 2 meters per second. The ball hits the ground at T1 and is in contact with the ground from T1 to T2. It leaves the ground and reaches its highest point at 0.9 meters above the ground. Now remember, when the ball reaches its highest point, the velocity is equal to 0. It then accelerates back down and reaches the ground at T3. It is again in contact with the ground from T3 to T4 and moves back upwards to reach its highest point again at a height of 0.5 meters. It then finally accelerates back down until it reaches T5. In 3.1, we are asked what is the maximum vertical height reached by the ball after the second bounce. Now between T1 and T2 is my first bounce, and my second bounce is between T3 and T4. The maximum height reached is then the 0.5 meters. In 3.2, we are asked to calculate the magnitude of the time T1 as indicated on the graph for a total of 5 marks. At T1, the ball hits the ground for the first time. We are therefore going to work with this first projectile path. Here we have the initial velocity of negative 2 meters per second. The final velocity with which it hits the ground is unknown, and it is thrown from a height of 1.8 meters. We also have our constant acceleration of 9.8 meters per second squared in the downward direction. From our equations of motion, we can see that we have enough information to make use of equation 3. We have the change in position, the initial velocity, we are looking for the time delta t, and we have the acceleration. The only problem with equation 3 is that it is a quadratic formula which could take a bit longer to solve. I would therefore rather make use of equation 2 to calculate the final velocity with which the ball hits the ground, and thereafter calculate the time using equation 1. Please note that all 3 vectors are in the downward direction, and therefore all 3 of them are given as negatives. The ball then reaches the ground with a negative 6.27 meters per second. We can now use this final velocity and substitute into equation 1 in order to calculate the change in time to solve t. Which gives us a time at T1 of 0.44 seconds. 3.3 says calculate the velocity with which the ball rebounds from the ground during the first bounce, for a total of 4 marks. In order to solve this problem, we would only have to make use of this projectile part of the path. We want the initial velocity with which it moves away to a height of 0.9 meters and a final velocity of 0 meters per second. We can now make use of equation 2. We have the final velocity of 0, we are looking for the initial velocity, and we have the acceleration as well as the displacement of the ball. Now we would take the displacement as positive, seeing as our displacement is in the upward direction and up is positive. Which shows us that the ball moves away from the ground with an initial velocity of 4.2 meters per second. The ball is in contact with the ground for 0.2 seconds during the first bounce. 3.4 then asks us, calculate the magnitude of the force exerted by the ground on the ball during the first bounce if the ball strikes the ground with 6.27 meters per second, for a total of 4 marks. In this problem, we are dealing with a change in momentum. My ball strikes the ground with an initial velocity of 6.27 meters per second and moves away from the ground with a 4.2 meters per second. And it is said that the ball is in contact with the ground with a total time of 0.2 seconds. In order to solve this problem, we can make use of Newton's second law in terms of momentum. Remember that the velocity is a vector and therefore direction is important. We took down to be negative and up to be positive. We then get a positive answer of 26.18 Newton, and seeing that it is positive, it is indicating the upward direction, therefore it is the ground on the ball. (3.5) says draw a velocity time graph for the motion of the ball from the time that it is projected to the time when it rebounds to a height of 0.9 meters. Clearly show the following in your graph: the time with which the ball hits the ground, the velocity of the ball when it hits the ground, and the velocity of the ball when it rebounds from the ground, for a total of 3 marks. For this velocity time graph, we are only plotting this initial first part until the ball reaches its highest point after the first bounce. We therefore have to go and note down the velocities that we have obtained. In the first projectile, we have an initial velocity of negative 2 meters per second, and it reaches the ground at negative 6.27. It also reaches its final velocity of negative 6.27 at time t1. At time t2, I have a new velocity of positive 4.2. My velocity then decreases to a velocity of 0. Note that these lines have to be parallel, seeing as they represent acceleration, which is a constant for a body in free fall of 9.8 meters per second squared. For this velocity time graph, I took down to be negative. If you took downwards to be positive, then your graph would be the inverse of this graph. In both cases, it is correct as long as you indicate which direction you took as positive or negative.